Hi guys, Mrs. Scott here. Let's jump right into today's lesson on how to measure and classify angles. First of all, an angle is a geometric figure that consists of two rays with the same endpoint. And we'll look at a picture of a few angles in just a moment. Alright, and there's four different types of angles that we're going to classify today. Okay, our first postulate for today is called the protractor postulate, which tells us that you can match up the rays of an angle with numbers on a protractor. In other words, you can measure an angle, and the numbers on a protractor range from 0 degrees to 180 degrees. Alright, so for example, say we have this angle here. We'll call it angle A. And this ray goes through 50 degrees on the protractor, and this one goes through 10 degrees on the protractor. Well, then the measure of angle A would be those two angle measures subtracted, and then you take the absolute value so you don't get any negatives. So that would be 40 degrees for the measure of this angle here. Alright, so now let's look at those four different types of angles. The first is what we call an acute angle, which is less than 90 degrees. The next is a right angle, which you use this square at the vertex to represent. And that is exactly equal to 90 degrees. An obtuse angle, which you could probably guess is greater than 90 degrees. And lastly, we have what we call a straight angle. And a straight angle, which forms a line, is 180 degrees. Alright, so now let's use a protractor to actually measure some different types of angles. So a protractor is this half circle figure, and we're going to use that to measure the angles formed by the streets on this map, and we're going to use the letters to name each angle, and then we're going to classify it as one of those four types of angles. Alright, so when you use a protractor, you have to make sure it's lined up so that the center point is on the vertex or the corner of your angle, and this here would be our 0 degrees. So make sure your 0 degrees is there. And then we'll go up by 10 degrees. So that's 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80, and 90. And your protractor should have numbers on it. Alright, so first of all, Cherry and Chestnut. Well, Cherry Street goes through 90 degrees. Chestnut Street goes through right between 10 and 20 degrees. We have 15 degrees. So if we subtract those, that tells us that creates a 75 degree angle. Alright, and now we're going to name it. So Cherry Street goes through A. So we have angle A, and it goes to E. The vertex is always the middle letter. And then Chestnut Street goes through point C. So that would be called angle AEC. It's less than 90, so it's an acute angle. Let's do those same steps with Raspberry and 10th Street. Raspberry Street goes through 30 degrees. 10th Street was our 0 degrees, so that's pretty straightforward. That's a 30 degree angle. And to name it, Raspberry Street goes through point B. The vertex is at E. And then 10th Street is point D. And it's still less than 90, so also an acute angle. And last but not least, Cherry and 10th. So Cherry Street goes through 90 degrees. 10th is 0 degrees, so that would be a 90 degree angle, which remember is called a right angle. And then let's name it. Cherry Street goes through A, and then the vertex is at E. 10th Street goes through point D. Alright, let's move right along here. The angle addition postulate we're going to illustrate this with a picture. So let's draw a picture of an angle. Let's call it angle ABD. Then we have this point C in the middle here. We'll call that point, I already used D, so let's use point C. So what the angle addition postulate tells us, if you want to figure out the measure of this entire angle ABD, what you can do is say that the measure of the angle ABC, this angle here, plus the measure of angle CBD, this angle here, those have to add up to give you the entire angle. So say this was 30 degrees right here, and this was 70 degrees right here. So if angle ABC is 30 degrees and angle CBD is 70 degrees, then the entire angle would be 100 degrees. Okay, so now we're going to use that same idea to figure out the measure of angle QST. If we know the measure of angle QSR is 88 degrees. Well, they also tell us angle QSR is 3x plus 1, so that has to equal 88 degrees. And then we can use our amazing algebra skills to solve this for x. So we end up with 3x equals 87. And 87 divided by 3 is actually 29. So x is 29. Remember, we still have to answer the question. We're finding the angle of QST. So don't just stop when you find x. Well, we know QSR is 88 degrees. And now we can plug in here our value for x. So 2 times 29 is 58 minus 6. That's 52 degrees. So the entire angle, QST, if we add up our 88 degrees and the 52 degrees, that entire angle is 140 degrees. All right, moving right along, let's do a little more practice of that angle addition postulate. Find the measure of each angle. Let's start with angle A. Notice that these two angles form a straight angle, which is 180 degrees. So that means A has to be 20 degrees. So that if we would add those two, we would get 180 degrees here. All right, so now we know this is 20. And likewise, we can use that same idea with angles A and B. Those form another straight angle. So angle B has to be 160 degrees, so that these two would add up to 180. Okay, let's look at the other side of the diagram. This right here is a right angle. So 75 plus what gives us 90? Well, 75 plus 15 gives you 90. So that tells us C is 15 degrees. And lastly, we have another straight angle here to find angle D. This is 90 degrees. So if we take 180 minus that 90 and 15 degree angle, that tells us angle D has to be 75 degrees. All right. Next, let's talk about congruent angles. And we've mentioned this term congruent before. Congruent means equal. So these are angles with equal measures. So they have to have the same number of degrees. We're going to use that idea in examples 4 and 5. First step, we're going to identify all pairs of congruent angles in the diagram. So if you notice that angle T and S both have one arc on each of them, that tells us that angle T is congruent to angle S. And that's what this symbol right here means, congruent to. And likewise with angles P and R, those both have two arcs on them. So angle P is congruent to angle R. All right, and now they give us some angle measures. So they tell us angle PQR is 130 degrees, QRS is 84 degrees, and TSR is 121 degrees. So that also tells us these two angles on the left as well, since they're congruent. And to find the sum of the angle measures, we can simply add those 5 angles together. If you add up all 5 angles, that tells us that this pentagon's angle measures add up to 540 degrees. Okay, our last term that we're going to discuss in today's lesson is an angle bisector, which is a ray that cuts an angle into 2 congruent angles. All right, so let's use that idea in examples 6 and 7. In example 6, they tell us we've got this angle CHS. So this is CHS. And angle CHS is bisected by a line. So we've got this line here that bisects it with point T forming angle THS. So this angle here has a measure of 34 degrees. Well, if this black line here is a bisector, that tells us this angle also has to be 34 degrees. So to find the measure of angle CHS, we just add those 2 angles together, and that tells us it would be 68 degrees. Okay, in this next example, we're going to throw some variables in, so we'll have to be doing some algebra here. In the diagram, ray BD bisects angle ABC. Find the measure of angle ABC. Well, first we have to find x. So if that ray there is a bisector, that tells us that these 2 expressions are equal. So we can say x divided by 2 plus 17 is equal to x minus 33. I don't like to work with fractions, so I'm going to multiply the entire problem by 2. So you can think of this as distributing that 2 into all 4 of these pieces. And that's going to cancel out this 2 here. So I've got just x plus 34 equals 2x minus 66. Now we can solve this just like we normally would. Let's get our x's all on one side. So I'm going to subtract x. I get 34 equals 2x minus 1x is just 1x minus 66. Then let's add that 66 to the other side. And we get 100. That's x. All right, so now we still have to figure out the measure of the angle. Let's plug that x in here. So 100 minus 33 is 67 degrees. Well, that tells us that the measure of angle ABC would just be 67 plus 67, since these are both the same. And that ends up being 134 degrees. All right, so for these last 2 examples, I'm going to send you guys a link to a video that goes through how to construct a copy and a bisector. So thank you guys for watching, and we'll see you next time.